Okay, so it's September 17th. We're finishing the last couple problems in 3-3, and we'll do 3-5 and then get into 4-1. All right, so on this problem, they're looking at increasing and decreasing, okay? So what we need to understand is we need to understand how we or the ability to walk up a hill or down a hill. Okay, so you read a graph from left to right, period. Um, so you'll walk upon this graph left to right. So when we start, and this is goes on forever. So we're walking downhill, right? Does that make sense? We're walking downhill to this point, right? And then we change and we're walking which way? Uphill. So we're decreasing as we're going along the X, we're decreasing, and then we turn around and increase, right? Y'all see that? Okay, so you tell the story about the X-axis, and the number one mistake is telling the story about the Y. Okay, when you're increasing, decreasing, you're telling it about the X. So this is what I tend to do. You're looking for transition points like mountains or valleys. Okay, those are going to be your transition points from increasing to decreasing. I don't think we had anything, at least I didn't see anything that was constant. Okay, and constant would be flatline. So it's changing at 2, right? Now, where does this graph start decreasing from? Where? Negative infinity. Where does it stop increasing? Infinity, right? So basically what I'm doing is kind of drawing just kind of without kind of creating 2 different segments, right? And I'm kind of, now I don't have to look at the graph. This is decreasing, right? And this is increasing. Or this is going down from negative infinity to 2, and then it's going up from 2 to where? So it's increasing, and we got to write it in the interval notation, right? It's increasing from 2 to infinity. But ladies and gentlemen, it's decreasing from negative infinity to 2. Note that 2 gets a parentheses in both situations. Why? I couldn't hear you. Do what? Yeah, there's closed out there. See? I mean, if that has to be an ordered pair, right? So it has to be there. Okay, what? Because it's a set value. No. No, it meets. It meets. Say it again. At 2 on the x-axis, it's neither increasing nor is it decreasing. I know you went out the back of a K building, right? Right? You go down the stairs, right? What do you hit? No, you hit a landing, right? And then you got to make a choice. Do I go out the door and go down, or do I hang a left and go down in the lower, the basement or the lower level, right? So a landing is really what you kind of consider this. You're neither going up nor are you going down, right? It's a transition point. So the transition point is neither increasing nor is it decreasing. Okay? Y'all good? So you'll use parentheses just about 99% of the time, unless it's a, well, let's see. Even then, they won't. In 1101, they take answers like that right there. If it was stopped, like dead stop, endpoint max, like an endpoint maximum, we would put a bracket, but they put a parenthesis. So a little disagreement in terminology on that, but 99% of the time it'll get a parenthesis. So, and we've answered these questions down here. So, all right. Now, oh, Lord help us. Only for what we see, they want us to determine intervals where it's increasing or decreasing. Then they want us to turn around and look at the points where you might have a local maximum or local minimum. All right. So first things first. Find me increasing, decreasing, or look at it and be able to set some kind of strategy to be able to figure that out. Okay. Now you cannot assume that the pattern is going to continue off the page. You can assume that they're going. One is left hand behavior is going up or continually increasing, right? No, right hand behavior. Sorry, right hand. I get my left, right. Right hand is going up, increasing, and left hand behavior is decreasing the whole time, right? Or at least when it leaves the graph. So that's the things you have to assume. So let's see what you can do. We'll give you, I don't know, what do you think? 15, 20, 30 seconds. All right. Let's look at mine compared to yours. So what I done was do you see the little, I went to a mountaintop, then I took my mountaintop back down to the x-axis and took my valley up back to the x-axis. And that's what I wrote on this number line, so to speak. And I created segments, right? Had negative infinity, positive infinity. What am I doing from negative infinity to -4? Well, I'm increasing. I'm walking up the hill, right? And from -4 to 4, I am going down the hill. And then from 4 to infinity, I'm going up. I don't know why that happened, but I'm going up, okay? So if we look at this from an increasing standpoint, it would be negative infinity to -4 or 4 to infinity. From a decreasing standpoint, we would go from -4 to 4. Any questions on that? No. Don't tell the story about the y-axis, right? Remember that I said that's your number one mistake? When you do an increase and decreasing, you want to grab those y values because you're like, oh, it went all the way down there. No, you need to take it back. Because you need to think about it like this, okay? Increase and decreasing. Let's take a trip. Let's go to Myrtle Beach. There ain't nothing there but water right now, so let's just go to Myrtle Beach. Okay? Yeah. No, we can go. I guarantee it won't be crowded. Anyway, so if I said, okay, we're going to Myrtle Beach, it takes about 4.5, 5 hours from now. We'll get there. It's like 200, 300 miles, right? So 300 miles, we think of in terms of straight line, right? Our brain goes, oh, that's just straight line. We look at it map. It's like flat, 2D, right? But if you've ever driven I-20, there ain't no way that thing's flat. Now on the other side of Conway, you will, last little bit to the beach. It's kind of flat and going downhill. But from Thompson, Georgia to Columbia, South Carolina and on, you're doing this. Yeah, you're doing hills, right? You're gradual and all that stuff, right? So we don't really care. We think about it in terms of straight line. Okay, so that's what you need to do. Think about it. It's 300 and something miles, right? Yeah, yeah. So say, hey, you're going uphill for X amount of miles, right? You're going downhill for these X amount of miles. I don't care how far in uphill and downhill I go. I just want to know from where to where does the elevation change, so to speak. Because am I walking uphill? Am I walking downhill, right? So take each mountain or valley back to the x-axis like I done here, and you'll be okay. That's why I do that number line. It's just a strategy. And it's a strategy to get you to think about the x-axis, okay? Strictly. No, I said it would, because you can't assume that this pattern is going to repeat. You have to assume that the right-hand behavior is increasing, left-hand behavior is decreasing off the page, right? We can't assume that this is just a sine wave that's going on. Yeah, because then we would have to consider on past this, and then we'd go like, oh man, where's it ever stop? Well, it's not. So, but that's what you need to do. Just kind of look at what you got and know that if it's going off to infinity, negative infinity, and then go from there. Now, let's look at this, because it said, okay, guys, local maximum and local minimums. Now, we talked about maximum minimums the other night, and we said, okay, when we was going over definitions, correct? First thing, there was local, and then there was absolute. What's the difference between the two? Yeah. Absolute is the highest point. Absolute maximum would be the highest point, right? We said, what was that, Clemens Dome up there, right? Off, yeah? No, yes. Yeah, that's the highest point. You can see 4 or 5 states or something like that crazy. That's the highest point there, right? Now, it's not the highest point along that mountain range, but it is one of the highest points in the area, right? So that would be an absolute. Now, a valley that you can look and nothing is lower than that, either to the left or to the right of that, then that's an absolute minimum, right? But if you got little hills and valleys in between that, and it's not the highest point nor the lowest point like this is, then you have what are called local, right? You can tell that this is a local maximum, mountaintop, right? This is a local minimum. If I stood right there and I looked left, man, I don't see nothing, right? But when I look right, look what I see. I see this right here taking off, right? Going forever down, right? Same thing here. If I'm up on this mountain, I look right, man, I'm good. Don't see a thing. But if I look left, I'm going to see this one continually going up, right? Does that make sense? Clear as mud. Great. That's excellent. Why? You can't hear me? Oh, well, I'll try to speak softer. I'll speak louder. All right, so let's look at this. All they're wanting is a point, right? So what's this point? Let me highlight this. They want that point there, and they want this point here. So what is that really? Oh, yeah, -4, 128, right? And then what's this? 4. Yeah, there you go. So this is your local max. And then this is your local min. Okay? And if you look down here how they got it, they have it as an ordered pair. The only other way that they'll ever express this or want you to ever answer it in is just y equals. Okay? So there's 2 ways that they can ask you for a representation. One, an absolute min being or local min being y equals something, the y value, or they could say for the point or up here they'll ask y equals or points. Doesn't really matter. Both of them are correct. It's just different representations. All right. Nah. In order to get an absolute max or absolute min, is you have to have a mountain or a valley, right? You understand what I mean by a mountain or valley? Yep. Okay. It doesn't create that, does it? Look at the endpoints as they leave left side and right side. They continually go up. It's got a transition. None. None. There's not an absolute in this one. They're locals. They're mountains and valleys, but not the highest nor the lowest. Right? Y'all good? See, y'all come to class just to learn about geography. All right. The demand for a product in thousands of units is given by D of x equals 110 over x, where x is the price of the product. Is this an increasing or decreasing function? Well, you got to know what it looks like, right? How many of y'all know what that looks like? Oh, don't be shy. Yeah. You say it's decreasing. I call it the Jane Fonda. You know why I call it the Jane Fonda? Well, it don't go past that blue right here. So all right. And this is what I mean by Jane Fonda. Yeah, you know, like this and that, right? That's like aerobic pose. She was the queen of aerobics, Jane Fonda was. You know that? She put out a lot of stuff, you know, yoga, not yoga, aerobic videos back in the 70s and 80s. No? Oh my gosh. I'm just curious. Yeah. Hey, y'all even know what a VCR is? Yeah. I think I saw one of them in the Smithsonian one time. You know, it's funny when you see stuff in Smithsonian's up in D.C. Um, that you had back when you were growing up. I think that's hilarious. Okay, so you know it's it's something like it's an inverse function, right? So it's going to do this. So if I look at it from left to right, let's see. This thing is doing what? Going up and then doing what? Oh, it's still going up. And then down here, because it doesn't, these are asymptotes, right? Lines set the function approaches, but never. So we got two of them, right? Two sets, vertical and a horizontal, right? So, well, I guess you could say it. And we won't go there. Asymptote equals over the line y equals x, but we could probably say that since it's over both. But anyway, that's a little bit deeper than what we need to for right now. But this is going up, right? So this function is always doing what? Increasing, right? So. Well, here, I'll show you. What was that, 110 over x, right? Yeah, okay, good. Um, hmm? Where's Zoom fit at? 0. Ha, ha, ha. There you go. Ah! It flipped on us. Ah. Okay, my bad. Yeah, it is. So it pays to graph it. Um, So it's in first and third, not second and what? Fourth. So that's bad. I'm just curious about something. Hold up. Uh-uh. Why is it not doing that? Inverse function. Okay. I just grabbed the wrong quadrants. I was thinking 2 and 4 for the basic. That's the basic 1 over x. It's actually 1 and 3. So in my mind, I grabbed 2 and 4. So does that make sense? So this is here. Let me do this. It's 1 and 3, not that. So it's like that. So it's not increasing. It's doing what? It's decreasing. Yeah. So I'm glad I looked at it. X is in the what? Denominator. So it has a restriction, right? So the question was, why do you draw it like that? Well, we can go back and so it can't be 0, right? That's the restriction. That's right for this one. So so what we're doing is, zoom fit. So there's asymptotes here. So here, and then what? It's decreasing, right? Yeah. So it's not going to touch here. It doesn't exist, right? So it also doesn't exist where? Along the horizontal. Okay. So it's actually acting like 2. Let me do this, because I want to show you something real quick. And this I need to put up on the website anyway. Yeah, that should be there. Let's see if I've got it. Not in that. Not there. Well, I don't have it. I thought I had it real handy. I was going to show you the 6 basic functions. I have to look for it. I think it's 113 either. Okay. All right, so there. Would that problem ever change like that? Not unless it's been reflected, right? Yeah? Okay. All right, so that's all the 3, 3. So let's go to what? 3, 5. Transformations of functions. Shift happens, right? Right? So when you are outside of the function itself, and this is what I mean by outside. Here's the function f of x plus some constant, right? Plus or minus. Then it's a vertical shift, either up or down, right? You're doing something after you evaluate it. Then you're going up or down. Okay? If k is negative, it's shift down. So there's the how-to. horizontal shifts are inside the function, okay? And that's the key, inside the function. And it's x minus h. So it's the opposite, right? That's what you got to make sure you understand. If it's a positive, like x plus 2, then that's really a shift 2 places to the left. If it's an x minus 3, well, normally you'd go negative would be left, but it's opposite, so it would be right 3, right? So pay attention to these. Excuse me. If h is positive, the graph will shift right. And if h is negative, the graph will shift left. Well, but when you put that in there, what happens to it? It changes size, right? So we'll do that. Just take into account that. All right, reflections. You have a vertical reflection and then a horizontal reflection. Vertical is basically reflecting over the x-axis, right? It's vertical, up and down. So the y values change. All they do is change signs, okay? So that's why they have right here negative f of x, right? Yeah? Compared to a f of negative x, which is a horizontal, that's about the y-axis. And if you think about it, if you're reflecting about the y-axis, who changes? The x values, right? So that's why it makes sense that it's internal f of negative x, right? So we're going to refer back to these. You got to make sure the understanding of these reflections and shifts are basically what's going to happen in the next couple of problems. All right, even and odd functions. I'll show you how to do an even and odd a lot easier than doing it algebraically. And what I mean by algebraically, you have an even function if the f of negative x is equal to f of x, right? If you plug in negative x's and everything comes back out to be exactly what you came up with, then you're good. It's even. But if it's odd, then the negative of negative x turns out to be f of x, then it's odd. Now, algebraically, you can chase yourself in circles on this, and I'll show you how to do it a lot easier, much easier, okay? And it works every single time. All right. So, even and odd. Vertical stretches and compressions. All right. If it's a times f of x, then you have a vertical stretch or compression, right? So if your a is greater than 1, it's being stretched. If your a is between 0 and 1, it's being what? Compressed. And then, last but not least, if a is less than 0, it's a combination of vertical stretch or compression with a vertical reflection. Now, that will mess you up if you have to think about what's happening to the graph itself when that's all happening. Okay? But we don't have to in this section. All we have to do is understand what is happening to the function based off what it's given. All right? So a times f of x, right? A times the function. Okay, vertical stretches or compressions. And then we could go back and check this to see if it is a vertical stretch or vertical compression, or reflection with a vertical stretch or reflection. All right. Did I turn this thing back on? Yeah, I did. All right, horizontal stretching. Look where the multiplier is. It's inside of the function, right? It's going to be multiplying the x value, right? So here's a list of criteria. If b is greater than 1, then it is being compressed by 1 over b. If it's 0, if b is between 0 and 1, then it's being stretched by 1 over b. And ladies and gentlemen, if it's less than 0, then there's a combination of horizontal stretch or compression with a horizontal reflection. Yay. All right. Questions? Yeah, I wouldn't know what to ask right now neither. So you're okay. Let's go work some problems. I think that's all. Combining them? Oh, my bejeebies. Look right here. Now, hey, we can get the shift up, right? Yeah? But what's that first one doing? That's a stretch because it's A times it, right? What about this one? That's a compression and a shift left or what? Right? Right. Well, they say stretch. Yeah, they stretch. Let me go back one. Yeah, okay. If it's greater than, but if it's between that, then it's. And then this one, look right here. It's being horizontally stretched and then horizontally shifted, right? Man. Horizontal and vertical transformations are independent. It doesn't matter which one you do first, okay? You got to make sure. But we're not going to graph them, so that's the good part. Or at least the problems that I saw in homework that I chose for you to work based off of this, we're not graphing them, right? Your son, horizontal, vertical. Okay, got it. All right. So for the following exercise, describe how the graph of the function is a transformation of the graph of the original f, right? So what's happening here? What are we doing? Anybody know? It's shifting left to right. It's a horizontal, right? It's horizontal shift. It's going which way? Nope. Yeah, that's right. So it's right, how many? 9. So select the answers, horizontal shift, 9 units to the what? To the right. Does that make sense? Remember, when it's a horizontal shift, it's the opposite, right? Because it's x minus h. Y'all remember that? No? Yeah, I would take these first sheets that I had, and I would kind of lay them out when I'm doing this. So I can go, yep, 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 yep. Okay? All right. Because I'm going to tell you, we, and I hate to say we, but you normally have been exposed to only vertical and horizontal with some compressions being vertically, I think. Let me make sure I get my vocabulary. Yeah, vertically. Where you've got something like a number greater than 1 and you put it on a quadratic and it makes it get skinnier, right? And then you put a number between 0 and 1 and it makes it do what? Lay down flatter to the y-axis, not to the y-axis, to the x-axis, right? So vertical stretches you've been exposed to, not so much horizontal. Okay. What about this one? What's happening here, guys? Here's your basic function. What's that doing? It's going up. It's vertical shift where? Up what? 14, right? So I'm not sure. I think it's like that, right? Something like that. Vertical shift, 14 units up, right? At least I hope it is. Yeah, me too. Okay. Any questions? This is outside the function. How do I know it's outside the function, guys? Yeah, but what does that look like? Because it's outside the function. What does it look like? Yeah, you go. Good job. See, the other one was inside the parentheses, right? Inside the function. You got to be careful about that. All right, so snap, crackle, pop. Square root 8 is shifted up 8 units, and to the left, how many? 6. So we got to make sure that we can write that. So let's give you 15, I don't know, 20, 30 seconds to see what you can do on this. Oh, now come on. Don't say yourself that short. Oh. You're only wrong until proven wrong, right? Oh, now come on. You could try. Give you 30 seconds. Go. Okay. Well, let's see. In the blank stairs. So square root of x to the left would be, to the left, 6 would be plus 6, right? And then what? Plus 8, right? And sometimes people write it like this. 8 plus the square root of x plus 6. Because horizontal shifts have to happen within the function. What type of function is this? Square root. Yeah. All right, so you may see it like that, or like what? The right one or the left one. Doesn't really. What's the difference? Huh? Yeah, we are moving the numbers. That's, yeah. Well, this commutative property of addition allows me to do that. It's like 2 plus 3 is the same as 3 plus 2, right? I'm not changing overall value. But when you have something that follows a radical, 9 times out of 10, people will put it, if it's just a number, they'll put it up in front of it because our eyes tend to merge that with a radical, right? So just be aware of that. Any questions? How'd you do? Were you able to get the plus 8? See? You're 50% there, right? And when you do a horizontal shift, it's opposite, right? So if I'm going left, that's really negative. But when, remember, it's x minus h. So when you subtract the negative, it becomes a, thank you. Good. Oh, my. Yeah. The tabular representations for the function f, g, and h are given below. Write g of x and h of x as transformations of f of x. Okay. Let's do this. Here's f of x. So g of x and h of x as transformation of f of x, right? Well, let's look at something real quick. Because so we pick a point, right? So let's pick some more. 1, 3, 1, 5, and then what? You okay with that? So what happened with g of x compared to f of x? What do you think? 0 became 3, right? So it went up by, well, let's see. So this one only went up by 2, right? That one went up by what? 4? And then this one up, how about, how many? Huh? 2. We can look at rate of change and see what type of polynomial it is. And then go from there. I'm going to look at this one real quick. One, one, one. That's just, h of x went down by 1, didn't it? That's the only thing. It went down. It was a vertical shift of what? Between these two? Yes or no? But why aren't we, unless it's got multiple on there, and guys, I want to tell you something. If it's got multiples on there, pack it up, go to the house. You ain't going to be able to figure that out. Unless it's a shift to the left or shift to the what? Right, or up or down, right? So, jeez Louise. It shifted them where? To the, hold up, let's think about it. To the right? So it took like the output, well, did it? Oh, no, it did. It shifted them which way? To the left. How many? 1. That's it. I prayed. What? You ready? Okay. So from f of x to g, do y'all understand that it's just a up or a what? Down. So they are keeping it just simple, right? So you good with this on the bottom one? That it is a vertical shift of what? -1. So it's going down by all of my outputs went down. What? 1 3 became 1 what? 2. 0 -1 became 0 what? -2. -1 -3 became -1 and -4. So my outputs went down, right? By 1. All right, so you good on that? All right, so let's look at g of x, right? Well, they have the same numbers, do they not? Look at your outputs, f of x and what? G of x. -5, -3, -1, 3, and 5, right? They're down there, correct? So let's look at what happened to our x's. Huh? So it was a shift to the what? Is it? I said left to begin with. My x value shifted which way, guys?
No, I'm sorry. Yeah.
My x values. I'm not looking at my y's, am I? I'm looking at my x values. What's happening? Because my y's stayed the same, did they not? Okay, so look at my x's. What happened to my x's? They all shifted what? 1 to the what? Y'all see that? This went beep. Yeah? Y'all see it now? No? Yes? Now, if that had vertical compression, stretches, reflections, all that, we could probably do reflections. But that's way more difficult if you had those. So they did keep it simple, right? Shift to the left, how many? 1, right? Okay, you're going to have to set this in and scratch your head on it a little bit, right? You're going to have to. So you'll be okay, though. Because all you know now is it's doing shifts to left or right, and it's doing what? Vertical shifts up. But look and tell. This is how you can tell. Look at my outputs. Did my outputs change compared to f of x? Yes or no? No. So you only shifted left or what? Right. Look at h of x down here. Look at my outputs. My inputs are all the what? Same. So who got shifted? My outputs, right? They're either going to go up or they'll go what? Down. Does that make sense? Y'all good now? That give you a little bit? No, still. We'll pray on it. It'll be okay. So, all right. So you're going to look at it in terms of what moved. Was it the X's or was it the outputs, right? And that's going to tell you whether it's a vertical or horizontal. Yeah. Mm-hmm. Yeah. There you go. Yeah, you got to write that, I think, or they may want you to. They may want you to do things like this. So that would be, yeah. And then this would be h of x minus 1, right? Does that make sense? Well, did it say write it in terms? Okay. So yeah, you're right. You're right. I'm just showing. Yeah, you're right. So these all need to be what? F's, right? And then what? There you go. There. You should be good. Now here's where the fun part happens. This is just a f of x equals absolute value of x, right? And it's been shifted. So write an equation for the graph function by using transformations of the graph of one of the toolkits, right? We don't have the toolkits, but that's an absolute value function, right? Now, normally, this would do this, right? Let me change colors. And then let me do this. Okay, so the purple represents the parent function, right? F of x equals absolute value of x. Now, note that it went through 0, 0, right? The origin. Now, where's the reference point? Well, it's 3 comma what? 1, right? So it's been shifted to the right how many? 3, and up how many? Okay, so the new one would be this. And I hate to say the new one. Fx. New, we'll do that. The new f of x is this. It is x what? Shifted to the right, so that would be, you would think positive, but it is really a what? It's a negative, and then you go plus 1. Done. So I'm using that 0, 0 reference, excuse me, to figure out what's happening to my basic absolute value equation. So it went to the right 3 and up 1. So to the right would be negative, up 1 is outside, so that's positive. If we went left, it would be a positive, right? Okay, any questions? Mighty quiet. I don't know if I just lost you, you jumped off the train, or what. Yes? Yeah, that's the parent function. Yeah. Nah, I'm just doing it as a tool to help you understand what is the parent function without any shifts, and then where did they move it? Does it make sense that it moved over 3 and up 1? Yeah. Yeah, the purple is just to have you a base of reference. Okay. For the following exercise, describe how the graph of the function is a transformation of the graph of the original. G of x is equal to f of negative x. So g of x is blank. G of x is f of x what? Y'all remember which one it is? I don't know. Look at it. It is a, yeah, horizontal, right? We say reflection about the y-axis, right? Normally when we talk about transformations, we're talking about reflection about the y-axis, but you could do it about a point or anything, right? So it is a, what'd y'all say, horizontal reflection? Yeah, okay. Now, how'd you get that? Looking at your what? Your notes, right? I mean, look, go figure out where on those things that I gave you, it looks like that, right? And when you do, you're there. Okay. I'm a betting man that it's a horizontal. I got a 50-50 horizontal stretch or horizontal compression. It's between 0 and what? I would say compression, but I'd have to go back and look. But that's just a guess. I'm looking. My first thought was stretch, but it is compressed. But it is a horizontal, right? Good. Yes. It's not greater than 1. No, it's 1/6. Let's go back. All right. No, you're right. You're right. Yeah. It's 1 over B, and B, if B is, yeah, yeah. It's 1 over B, compressed by 1 over B, right? Oh, yeah. No? Yeah. Right? That's it. You're right. Yeah. So let's go back. Here. We'll. Okay. All right. So what is B? Nope. Because it is this. F of BX, right? Yeah. Yeah, that's what we had, right? Yeah. So B is 1/6, right? B, y'all agree? Yes or no? Lord have mercy. B is 1/6. Now let's go back and look at our thing. Then it ain't that. Yeah, you got 6 times, right? So you press the first press. But what happens when you get to a test? You only get 1. Hopefully. All right. So F of B times X, right? Where B is a constant, is either a horizontal stretch or compression, right? So with B, which is, it's this, B is 1/6, right? So B is between 0 and what? So it would be a stretch. All right. You okay? Look. Let's look at it. Here. It's not that. Look, we can make up another one. F of 2x. What's B? B is 2. Now let's go back. Now, B is 2, right? So 2 is greater than what? So that would be a horizontal what? This right here, when you jump to this is where you jump to. Yeah. And listen, that's where your eyes are going to go to. Why? Because it is already a fraction. But what do you do first? Identify the who? The B. Yeah? Okay. So you don't have to worry about graphing it, right? What's there be some you have to graph it? I hope not. Y'all going to come back in and tar and feather me. Okay. What about this one? Hey, graph the function f of x plus 5. Well, first off, what is it? What is x plus 5, guys? Is it inside the function or outside the function? It's inside, so it's a horizontal. It's a positive. Positive normally be right, but it's the opposite on that, right? So it would be to the what? Left 5, right? So it'd be 1, 2, 3, 4, what? 5, right? So 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, right? There. And then you have to graph it, right? And it's really not that. Y'all see what I done? I found where it crossed, and it was 2 away from here, and it was 4 up, so I went 2 away, 4 up, 2 away, 4 up, right? That has to hold true, because all I'm doing is taking it and moving it to the left 5 spots, correct? Yeah. Because if it's a horizontal shift, it's opposite of what's there. Remember? There you go. It's x minus h, right? In order to get a positive, that 5 had to be an negative, right? Yeah. Okay. So let's look at this one. What are we going to do this? F of x minus 3 minus 1. What's happening? It's going right 3 down what? So let's take this point, 0, 0. Let's go to the right, 1, 2, 3, and down 1, right? So that's where my new one is, right? So if I go over 1, it crosses at grids, right? And let's go over 2. That's still 1, 2, 3, what? 4. So 1, 2, 3, 4. There you go. You good? What'd I do? I ain't go up. No, dude. No, I went 4. I didn't go to 4. I went up 4 spots from where I was at, right? Oh, yeah, yeah, yeah. No, I'm good. I'm good. I'm good. Because I went down 1, right? So my 4s ought to be dropping. My outputs ought to drop by 1. Yeah. All right. Can you talk yourself out of answers on this? All day long. So, here's what I would suggest, whippersnappers. You got 6 opportunities on these before it gives you another one, right? Right? Because we said y'all wanted 6, right? You got to see 6 times to answer it wrong, right? Before it gives you another one. Okay, so get it right. And then can't you tell it to give you another one? Yeah. Practice. Sit there and just keep practicing on it. No, well, get it wrong. You know, after 6 times, you could probably put together every combination that gives you that. So you're probably pretty good to get it on first try. But then do it again. No, 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 no. Once you hit submit, it's done on each problem, right? Each problem has an individual submit. Now, you can jump all around you wanted to, right? Yeah. It should move freely. Yeah. You click any problem down through there. Sure can. If you go to the next, if you hit next problem, it's just going to sequentially go. But you can click on any one you want to. Yeah.
Is there a reason why they don't let you edit your why they don't let you go back and figure out? Yeah, because I had an example of that yesterday. Like, I don't get it because like it's already timed, and then like
Yeah, but you already know this wrong. You only get one submission on that problem. So if you get to go back in and redo it, then that's 2 submissions, right? Right? Eh.
Because like it makes more like how's that any different than like we did it on the paper and then we'd be like, oh, I messed up on it, then you can go back and fix it. But when you're on the computer, it's just like once you submit it.
Yeah, but you don't have to submit it until everything's done, right?
You submit the question, but like not the overall test. Like will it let you go back? Yeah, that's what I'm saying. Like
Let us pray for test anxiety. That's fine. Listen, I can't. I mean, ain't much I can do with that. Okay, so it is what it is. So anyway, let's look at this one. So given the graph of f(x) equals x squared as shown, graph the function negative f of x plus 2, right? So let's look at our transformations. First off, what is the x plus 2 doing to it? Yeah, it's going left how many? Whew. 2, right? Correct? Now, what does this negative do? It'd be a vertical flip, would it not? Correct? So instead of opening up, it's opening which way? Down. So it's going left 2, 1, 2, and now it's doing what? Yeah, it's going like that, right? Reflecting over the x-axis, right? All right. Questions? It would be a vertical because your y's are changing, right? You, yeah, yeah. Now I'm about to mess with you because we talk about reflection over the x-axis, right? Right, which means your y's change, right? So that's why it's vertical. Your y's go from positive to negative or negative to positive, right? It's this. It ain't shifting this way. It's going this way. It's like that, right? It'll mess with you. So what do you need to do? Take those sheets that got all your rules on it and go, which one is this? And what does it do? That's what you got to do. That's the only way you can, that's your game plan. and a lot of prayer. So, and you got 6 times to look at every problem, right? Right, on homework? Yeah? Okay, good. So,
And if you get to like number 5, you hit try a similar question or something, and it restarts.
yeah, if you hit a try similar, yeah, then it resets it back to 0, right? Yeah. Really? Okay. Well, remember, we took it to unlimited, right? So you never did get that option until we got back to it. Y'all wanted to make it a little bit less, right? So we made a little bit less, right? Yeah. Okay. All right. So, hey, I know what this plus 4 is, but talk to me about that one. What does that 4 f of x, what does this do? We know that that's up 4, right? That's a vertical shift of 4, right? So what does this do? It's something times the function, right? So was it a times the function? Was that how it was written? I don't know. You got to go look. Right there? It's this one, right? A. If A is greater than 1, it's a what? Vertical stretch. So what was A? A was 4, so there you go. Vertical stretch. Bada bing, bada boom. Y'all good? All right. So how you going to graph that? Well, watch this. Would you take, like me, I would go this point, I'd go that point, I'd go that point, right? Now, you're multiplying your output by what? 4, and then you're adding 4 to it, right? So the output here is 2, so 2 times 4 is 8. Then I'm adding what? Right? So that would be what? Way on up there, right? Would that be correct? Yay or nay? Well, here. You want to nerd out? Let's nerd out. Because if you see this, you're like, no, I don't want to do that. Let's do it. And this is the real beauty of this, okay? You're like, I don't want to do that. Well, yeah, you do. You just don't know you do. I know. Just give me the answer. That's all I want. Snap, crackle, pop. There. Okay. Okay. Y'all good there? So what I'm going to do is I'm going to force it to be just a little bit there. And then I'm going to open this up just a little bit to 14. Then I'm going to hit graph. There. So all it done was shift it over a little bit, right? Like moved it. All right. So now we're going to come in. We're going to do what? We're going to take this, and this is really cool because it's colored. We're going to times it by 4. So 4 times the what? Square root of x, right? And then we're going to turn around and add what? 4 to it, right? Correct? Then we hit graph, right? Hey, look at that. What happened? Let's go. Zoom fit. Hey, look at that. Okay, so what did we chose? Let's go back and look. Because we were like, oh, let's see. This ought to be what? We said that at 4, our new points ought to be what? 412? And then what? 9. Let's see. 9 times 4. No, that's 3. 3 times 4 is 12. So that's 916, right? And then 0. Yeah, and then 4, right? So there's my new points, right? I'm about to show you in a minute. Let's just make sure it's right. So y'all remember 0, 4, 4, 12, 9, 16? Y'all ready? Here we go. Table. All right, I'm going to do this. Now we're going to go this, and we're going to go. Man, ain't it cool to know how to work one of these? It's like the bomb. So we go Z. Oh, wait. Hold up. 0, 4, 9, right? Sweet. 0, enter. 4, enter. 9, enter. Booyah. There we go. Is that what we got? 0, 12, 16, did we not? Yeah or nay? Oh, my. Meditation. All right. Y'all look. Look at these points. What do these points that I've circled represent? Where it crosses a perfect what? Perfect grid, right? So if you do 4 times 0 plus 4, it's up where? It's up there at 0, 4, right? This output is what? 2. So listen, it says 4 times f of x. F of x is nothing more than y. So 4 times the output plus what? 4. So 4 times 2 is what? 8. 8 plus 4 is what? Thank you. Now let's go to the next point. It is what? 9, 3. 3 times 4 is what? 12. 12 plus 4 is what? 16, right? Okay, so I don't like it because they use both 4 multiplier and then a 4 up, right? Because you talk about 4s getting confusing. So I took my output and multiplied it by what? Right? And then I just added 4. That's all we're done. Right here, there's my output, 3. That's my y value, right? Yeah? So I'm looking at the outputs, right? Because f of x is nothing more than the y value, correct? Yeah or nay? Okay. All right. Let's go. Does it help to see a visual representation of that and looking at a table too? That's sweet. You don't get that anywhere else but here. Rick may do it. But I don't know if he's got the emulator on this thing. But if you really don't want to know how to learn how to use one of these graphing calculators, take Math 1101. We'll teach you how to do that. That's pretty cool. You can do everything with it. Everything. You solve every equation you ever wanted. Huh? Yeah. If you don't want to do that, I mean, if you don't like math, then you probably shouldn't take 1101, right? Huh? Well, you're going to end up knowing or seeing that you could have done this in a lot less time on a calculator, which probably make you a little bit furious. But you can do it, dude. I mean, it's fine. All right, so follow the exercise. Sketch the graph. Oh man. So sketch it. Well, first off, what is the parent function? No. What do I mean by parent function? The original. What is it? Yeah. The original is a quadratic or parabola, right? Its vertex or its transition point is what? 0, 0, right? You with me? All right, so to man, they want us to sketch the graph of a toolkit. Okay. The what now? It's a quadratic. It's a quadratic. That's in vertex form. It's quadratic in vertex form. So man, okay. So let's choose -2, -1, 0, 1, and what? 2. Can we do that? So if we look at this from a standpoint of just x squared, then that's what our outputs are, right? You agree with that? Yay or nay? Okay, so we're going to shift it 3. So the x's are going to be shifting by how many? 3 to the left, 3 down the number line, right? Y'all with me? Oh, don't give me that now. Come on. It's going to be easy. Here's okay. So if I'm at -2 and I shift it 3 to the left, where am I at? Thank you. If I'm at -1, shift it 3 to the left, where am I at? -4. If I'm at 0, shift it 3 to the left, where am I at? If I'm at 1, shift it 3 to the left, where am I at? -2, right? If I'm at 2, that'd be at -1, right? So that's the shift on the what? X's, right? Y'all agree? Yay or nay? Okay, now let's go take care of our outputs. Because what are we doing our outputs now? Oh, wait. Yeah. That's f of x there. That's fx, right? And then what are we doing to our output? Multiplying it by what? 2, and then adding what? Okay, so 4 times 2 is how much? 8. 8 plus 2 is what? Thank you. One times 2. Uh-huh. What's your output? No. That's the x value. That's our new x, right? After we shifted it 3 to the left. Yeah? Okay, now we're checking our output. Because it's 2 times our output plus 2, right? Because this right here, x plus 3 squared, is really our function. You agree? That's our f of x. So we're multiplying our output by 2 and adding what? 2. Output's 4. 4 times 2 is what? 8. 8 plus 2 is what? 1 times 2 is what? Plus 2 is what? 4. Whoa. Uh-uh. Uh-uh. Our x's took care of the shift left, did I not? Now we're looking at the outputs to y's, right? So don't go back to that -5. You're looking at the outputs, right? So that would be 4. Then that would be what? 2. And that would be 4 and 10, right? Yay or nay? It sounds right. Looks right. I hope it's right. Then you graph those. And that makes it a lot easier, right? Yeah, because you like graphing points, correct? Yeah, exactly. It is. So I gave you 5 points, right? Vertex and 2 points to the left, 2 points to the right. So don't take my word for it. You do it, okay? Outputs. Look, guys, you got to make sure you understand this. This is 2 times f of what? X plus 2, right? That's really what you're looking at. And fx is the same as what? Y, right? Man, sweet. Now we get to tell if it's even, odd, or neither. Hmm? All right, y'all ready? Okay. Here's the rules. I do it by points. Okay? What I mean by I do it by points, I don't do the algebra on it. That's cray-cray. Because if it's truly even or truly odd or neither, the points will come out where they need to be. So listen to this. A and negative A, they got to come out with the same outputs. That's exactly right. An A and its opposite has to come out with the same outputs. Right? So let's look at odd. A, negative A, B, negative B. All right, so what I just wrote here says this. This is in Palmer terms, okay? For even, if you pick a number and its opposite, they better have the same output if it is even. Okay? That holds true. If it doesn't, then it can't be even, period. Cannot be an even function. Now, let's look at it, criteria for it to be an odd. An x value and its opposite, right, has to give you the same outputs, but different signs. So it'd be kind of like a first and third, second, fourth type quadrant thing. You know what I'm saying? Does that make sense? No? Positive on output has to be a negative, right? Positive, positive, negative, negative, right? Yeah. So here, pick a point that goes through a perfect grid, please. Pick a point on this graph that goes through the perfect grid. Which one do you think it is? I like this one. Oh, snap. Well, here, 2, 0. Yeah, but what's the opposite of 0? Yeah. Huh. Yeah, I wouldn't hang my hat on that one. You want to do that one? 2.5 and what? 5, 2.5 and 5? Y'all okay with that? Okay, now. So if it's 2.5, it has to be negative 2.5, right? Y'all agree? Yeah? Let's go to negative 2.5. Snap. Where's it at? Way down there. It's definitely what? Not what? It definitely ain't negative 5. Would you concur with that? And it's definitely not who? 5. Are y'all okay with that? So therefore, it's neither odd nor even. It is what? Neither. That's it. It ain't even or odd. Okay, even. Okay, here. Even has symmetry about the y. It's a parabola. Think about a parabola with the vertex setting right on the y-axis. And when you fold it, it has symmetry, right? Okay, now, when it's odd, then it's symmetrical. It's like a vertical and horizontal to both, which is nothing more than just a reflection about the y equals x, right? Which would mean that if it's in the first quadrant, it would end up in the third quadrant, right? If it's in the second quadrant, it would end up in the fourth, right? It's like you're folding it about a line y equals x, right? Symmetry about that. When it has a vertical and a horizontal both, that's really what you're doing. Okay? So, I'm going to put a question mark because we can't really tell. But we know it ain't who? 5, right? And we know it ain't what? -5. So we're good, right? So this baby is, guess what? Neither. See, you know beyond a shadow of a doubt, right? Yeah. Pick a number across this grid. Something has a different 0. Shoot. We could have done that, but it still would have been 2 and -2. Does it give me 0? Nah. It doesn't, does it? So it's neither. You see what I'm saying? If I chose 2, 0, then my next value that I got to check is -2. Now, if it came out to be 0, then, hey, I would say it's what? Would you say it's even or would you say it was odd? Really? What's the opposite of 0? Ah. So, yeah, that's I never thought about that, but no, I don't think that's, yeah, I wouldn't do that. If it was, but this isn't. I know it isn't. Look, if I fold this joker right there, is it going to line up on the other side? Yes or no? If I take this joker right here and do this, about that line right there, flip and then flip. If I took this right here and flipped it, would it look like it been, no? Nah. Thank you. All right. Yeah. Okay, now we get to the equations, right? And this is where people go, algebraic, right? They made y'all do it algebraically, did they not? Y'all remember this? This has been 11th grade math, even in odds. It's all a blur, right? I just paid attention. I went to lunch when they told us to. All right. That's the only period I look forward to. It's lunch. I get to use my head on the ice machine. That's the only time I get to use my head. Dispense my ice, you know. Really? No. All right. So listen, guys. Pick an X value. Okay. Now you're just nerding out, okay? No. Okay. 1 and what? Okay. Evaluate 1 and -1 in those equations. Let's look at their outputs. I will give you 84 seconds. All right. So that's what I got. Did you get that? So based off of what we have already discussed, looking at ordered pairs to determine even or odd, what can you say this is? Is it even? Why? The outputs are not the what? The same. All right. Is it odd? Yes, it is. Because it came up with the same outputs, but different what? Signs. No. Sorry. I did. Okay. Well, let me go back and explain it. Because don't think a negative has to go with a negative, okay? On this right here, on the odd. An X and its opposite. X and its opposite has to have outputs that are the same, but what? Opposites. It doesn't matter if the negative's up top or the negative is down in the bottom for an output. Is that better? Yay or nay? So you're looking for, look at it like this. For an odd, you're looking for the same outputs, but different signs. Thank you. So this is what? Thank you. Now, can you do the next one? Huh? Well, I've got an idea of what it is, but we'll see what you have. Okay. So what y'all pick? 1 and, oh, y'all staying with those little numbers, aren't you? Huh? All right. I know. That was too much for a cube. Yeah, it was. Okay, so 1 squared minus 5 equals what? Negative what? 4. Negative 1 squared minus 5 equals what? X and its opposite. What did it give me? Same what? Output. So this is what type of function? Thank you. I know beyond a shadow of a doubt. That's pretty cool. That's why I like this. The algebraic way, where you say f of negative x, that gives you what you got, came out, and all this other stuff. Nah, I don't like that. That's too confusing. I know. Now, whew, okay. Huh?